Hello everyone. We have already discussed in the previous video how a moving coil galvanometer works. We have seen that when we send current through a rectangular coil placed in a magnetic field, it experiences a torque. And because of the torque, the rectangular coil gets twisted in a galvanometer, and that value of twist is directly proportional to the current flowing through the galvanometer, and in a linear scale we actually measure the value of that particular current. Now in this video we are going to actually see how we can increase the sensitivity of a galvanometer. First of all, we will discuss what is sensitivity of a galvanometer, what are the factors which actually decides the sensitivity of a galvanometer, and then we will also discuss how we can increase the sensitivity. And at last in the video we are going to discuss a term which is known as figure of merit of a galvanometer. So go through the video very carefully and see to that if there is any doubt after going through the video, you can post me the doubts. So let us see how the sensitivity of galvanometer is explained here. See, when we consider sensitivity of a galvanometer is said to be sensitive, that is more sensitive, if it shows large scale deflection even when a small current is passed through it or a small voltage is applied across it. I think it is very clear to you. For a small current or a small voltage applied across the galvanometer, if it gives a very large deflection, we call the galvanometer to be more sensitive. So sensitivity gives the measure of deflection for a small amount of current or for a small amount of voltage applied across it. Now, first of all, we will discuss current sensitivity, and then we will discuss voltage sensitivity. By current sensitivity, we mean that it is the deflection produced in the galvanometer when a unit current flows through it. That is, the deflection or the twist per unit current. In the previous video, we have mentioned the value of twist or the value of the angle by which the galvanometer coil rotates. It is given by alpha. So alpha upon I is the current sensitivity given by Is, which is alpha upon I. The value of alpha is NBA I upon K. So the value of alpha by I will be NBA upon K, where N is the total number of turns of the galvanometer coil, B is the applied magnetic field by the horseshoe magnet, A is the area of the rectangular coil, and K is the torsion constant. This constant depends on the phosphor bond strip on whose support the whole coil is hanging. So I hope this current sensitivity is very clear to you. The unit of current sensitivity will be division per ampere. Okay. Now let us discuss voltage sensitivity. Now it is defined as the deflection produced in the galvanometer when a unit potential difference is applied across its ends. That means if we take a galvanometer, it has two terminals, and across the two terminals, if we connect a particular source of potential difference, then we will see that there is a deflection. That deflection per unit potential difference will be the voltage sensitivity. So it will be the deflection, that is alpha upon the voltage. So Vs represents the voltage sensitivity, which is alpha upon V, and V is IR, so it is alpha upon I divided by R, and alpha upon I is the current sensitivity whose value was NBA upon K and divided by R. So obviously voltage sensitivity can be considered as the current sensitivity divided by the resistance. I hope this is very clear to you. Here you see, voltage sensitivity is equal to current sensitivity by the resistance of the rectangular coil of the galvanometer. Now you can easily determine here the factors on which the sensitivity of a galvanometer depends. It depends on N, that is the number of turns of the coil. It depends on the applied magnetic field B here. Then it depends on the cross-sectional area, the surface area actually, the surface area of the rectangular coil, and the torsion constant K of the spring, and the suspension wear. So K depends upon the suspension wear, which we consider as the phosphor bronze strip, which is more suitable, having larger value of tensile strength. Now, since how we can increase the sensitivity of a galvanometer, we have seen that the sensitivity of a galvanometer depends on NVA upon K. So naturally we can increase the sensitivity of a galvanometer by increasing the value of the number of turns. But there is a particular limit to the number of turns. If we go on increasing the number of turns to increase the sensitivity, in turn the resistance of the rectangular coil increases, and the rectangular coil becomes very bulky. So it is not possible to increase the number of turns after a certain limit. Then we can increase the value of applied magnetic field. It is the by using the strong horseshoe magnet, we can actually increase the value of the applied magnetic field. Then we can increase the area of the coil. If we increase the value of the area, the sensitivity will increase, because the sensitivity is NVA upon K. But the area cannot be increased after a certain limit, because if we go on increasing the area, the galvanometer will become bulky and unmanageable. Okay, and lastly, we need to decrease the divided by K. So we need to decrease the value of torsion constant K, because sensitivity is NVA upon K. So we need to choose a material of which hangs the by whose support the rectangular coil hangs upon. We need to choose the material in such a way that the value of the torsion constant of that material is very small, and which comes out to be the phosphor bronze strip. So phosphor bronze is used, which has a very small value of K, so that we can increase the sensitivity of the galvanometer. So I hope that you are clear about how we can increase the sensitivity of the galvanometer. Now see here, advantages of a moving coil galvanometer. So what are the advantages that we are going to discuss? The first advantage is, as the deflection of the coil is proportional to the current passed through it, so a linear scale can be used to measure the deflection, which is an easy method of measuring the value of current. I hope this is clear. The current which is passed through the rectangular coil, it is directly proportional to the deflection or the twist. So the deflection can be measured in a linear scale. More is the deflection, more will be the value of current. So an easy way of measuring the value of current on a linear scale. Now, a moving coil galvanometer can be made highly sensitive by increasing simply N, B and A and decreasing the value of K. So we can increase the sensitivity of a galvanometer quite easily as compared to other current measuring instruments, where it becomes a little bit difficult to increase the sensitivity, but here it is easier for a moving coil galvanometer. As the coil is placed in a strong magnetic field of powerful magnet, its deflection is not affected by the external magnetic field. This enables us to use the galvanometer at any position. I hope this is very clear to you. We are using a very strong horseshoe magnet. So if we are using a very strong horseshoe magnet, because of that there is a within which the rectangular coil rotates. So it is not affected by any external magnetic field, because the magnetic field on which it is rotating is quite high. So it is not affected by any external magnetic field. So we can place it anywhere without considering that what kind of magnetic field is there. And lastly, as the coil is wound around a metallic frame, the eddy current produced in the frame brings the coil to rest quickly. Now, the concept of eddy current you have not studied till now, which you will study in the next unit, that is electromagnetic induction. For the short knowledge, just I am giving you a hint what exactly eddy current means. We have studied electric flux. In the same way, there is magnetic flux also. So when the magnetic flux changes through a surface, then a current is induced in the surface, and that circulating current is known as eddy current, and which opposes the cause which produces it. That means, suppose you take a metal, and in that metal, if you change the magnetic flux, a current will be induced in the surface of the metal, which will oppose the cause which produces it. Now, when the rectangular coil reaches equilibrium, because of its inertia, it moves forward and then again it comes back. Suppose it reaches equilibrium here, but it will move forward and again come back, and it will start vibrating like this. So it is covered by a metallic substance, metallic conductor. So magnetic field through the metallic conductor changes, and eddy current is produced, which opposes this kind of motion. So it sometimes is also known as dead-beat galvanometer. Dead-beat galvanometer, that means the beats are almost negligible. So I hope this is very clear, but still then if it is not clear, in the next unit you will discuss it with more intensity. Now next is some of the disadvantages are also there. The main disadvantage is that its sensitivity cannot be changed at will. We need to do so many things, so many adjustments, so that the sensitivity can be changed. Okay, we have to change the value of N, A, so these are difficult things. Now, all types of moving coil galvanometer are easily damaged by overloading. So that is naturally a problem in every electrical appliance. A current greater than that which the instrument is intended to measure will burn out the hairspring or the suspension. So that is a disadvantage of moving coil galvanometer. Now we will discuss the figure of merit of a galvanometer. By figure of merit, it is actually the reciprocal of current sensitivity, or we can define it as the current which produces a deflection of one scale division in the galvanometer. That is current per unit deflection. So the figure of merit, which is given by capital G, it is current per unit deflection, I upon alpha. If you remember, the current sensitivity was represented by alpha upon I, so it is I upon alpha, so it is the reciprocal of the current sensitivity, and it is given by K upon NBA. So I hope this whole thing, sensitivity concept and the advantages, disadvantages, everything is very, very clear to you. But still then, if you have any doubt, you please post me the doubt so that everything can be taken care of very clearly. And it is a very important topic, so go through it very properly. Thank you.